Today I had intended to release another video showing a complete expert advisor, and as I normally do, I wanted to show writing this for both MQL4 and MQL5. But then each time I do that, I spend a significant amount of time showing the differences between MQL4 and MQL5 and describing the same things again and again. And the one that bothers me most is describing the difference in the way technical indicators are called. Now, I'm not saying which of the methods of calling technical indicators is better. I don't actually have a preference, but they are different, and different in such a way that they complicate the presentation of the expert advisors and the indicators that use them. So what I've decided to do instead is take a more modular approach to the future experts and indicators by creating some classes that can be used that will look the same for MetaTrader 4 and MetaTrader 5. Of course, inside those classes there will be differences for 4 and 5, but for the calling applications they will look and work the same way. So this video I will simply create the base class and a moving average and a MACD class to show you how to create those classes, and then in the next video I will actually create the expert advisor to use these, and in future videos I'll be using these and possibly developing additional technical indicator classes. So let's go to the code now, and I'll show you how to write the base class first and then the moving average and the MACD class. Now I'm starting with the MetaTrader 4 editor, but what I write will be for both MetaTrader 4 and 5. So using the Orchard folder inside, include Orchard, and I've already created a folder here called indicators, just with right click and create folder. And I'm going to use the wizard now and take this step by step through creating. And the first thing I'm going to do is create a base class for these indicators. So I go new file, new class, next, and my base class is going to be called C indicator base. And you can see that the file name here has been modified slightly. The C has been removed and it's called indicator base. That's just something the wizard does. It recognizes that it's convention to begin class names with a C, so it removes that and creates a file name called indicator base. You can change that if you like, but it's not a bad convention. And there is no base class for this. The author and copyright remain, and then I just click finish. And so here is the template for the indicator base class. Now I always modify this because I don't like the format that the template creates. This won't change any of the functionality. I'm just going to change the appearance. First, I don't like that comment block, so I'll replace that with a new block. These statements, the copyright, link and version, can remain, and the property strict. The class is C indicator base, has private, public, and the class declaration ends with that semicolon. I don't need these comments, I don't like those. So that's tidied up the comments, and finally I'm just going to shorten the indentation on these two. Alright, so now I have the template for the C indicator base class, and what I'll be putting into the base class is everything that's common for all of the indicators. Now if you're unfamiliar with using classes and object-oriented, the syntax is simple. It begins with the class keyword and then the name of the class, and you'll see some variations to this when we create the child classes later. Then an open bracket, and the class declaration begins with a closed bracket and semicolon. There are two ways to write these classes, but rather than confuse you, I'll just go through one way. There are three different groups of variables and functions in a class: private, public, and protected. Protected doesn't show up here, but I'll just create that now. And the difference between these being anything that shows up under private can only be seen and used by this class. Anything under protected can be seen and used by this class and any class that inherits from this class. And we'll see inheritance when I create specific indicators for moving average and MACD soon. And anything in public can be seen and used by anything that uses this class. The two key functions that are created when you first use the wizard are the constructor, which is just the class name followed by two open parentheses by default, but we can change that, and then this is the destructor, which is also just the class name but preceded with a tilde. The constructor is always called when you first create an object of this type, of the type C indicator base, and the destructor is always called when you finish using that and destroy the object. So this is where you would put cleanup code, and this is where you put code you need to run when you first create the class. You can see that these function names don't have a type. They are void by default. The constructor and destructor are void. There are no arguments in these functions as they've been created by default, and I'll leave them like that, but in the child classes that I create there will be some arguments. And then the function just has a semicolon here. That means this is a simple declaration of the function, and the actual function appears down here. So remember, the class declaration ends with this bracket semicolon. Remember the semicolon, that's important. And then here is the constructor function, and all functions for class functions begin with the class name, 2 colons, and then the name of the function. Remember, the constructor is just the same as the class name, so that's why it appears as C indicator base, double colon, C indicator base. And the destructor appears as class name C indicator base, double colon, and function name, which is tilde C indicator base. I'm going to declare some variables for use by this class first. These are very similar to the global variables that you would find when you're not using object-oriented programming, but when they're within the class statement, inside this class and down to the closing bracket, then they are for use by the class at a global level within the class. Now first, I have 2 variables that are only going to be used by the MQL4 version of this, but because they're just variables, it doesn't hurt to declare them, and in MQL5 they'll simply be unused. And they are the symbol and the time frame. These are used in every technical indicator in MQL4, so rather than redeclare them in each of the child classes where I create the individual technical indicators, I'm just going to put them here once in the base class. And now, specific to MQL5, MQL5 handles indicators in a different way, in that it creates a handle to the indicator and then a buffer to store the values that come back from that indicator. Now, these are not used in MQL4, but just like the symbol and time frame, it doesn't hurt to declare variables, so I'm not putting any logic around here to hide them from MQL4 or MQL5. So I've declared an integer for mHandle and a double array called mbuffer. Now I've placed these in the protected section because the child classes that inherit from C indicator base will want to be able to access the symbol and the time frame for the MQL4 versions, or the handle and the buffer for the MQL5 version. So by placing them here in protected, I can use them inside the C indicator base class, but also anything that inherits from C indicator base will also have access to these variables. And now I'll declare some public functions. These are public because they are going to be used by the expert advisor or indicator that creates objects of this type. And the first is just an isValid. I need this for metatrader 5 because, as I said, metatrader 5, you create or you assign a handle to an indicator, and that can fail and would return an invalid handle value. So when I instantiate, and instantiate is the term for creating an object of type C indicator base, when I instantiate an object, I want to know if the creation of this handle has been successful, and if it hasn't, then I need to handle it in much the same way that I would if I simply created the indicator inside the code. So I can just test this isValid function from the C indicator base class. And as you'll see soon, when I create the child classes, I won't actually be creating an object of type C indicator base. I'll create an object of type C indicator MA or MACD. But because this is public, it is also available in the child classes that inherit from this. So I can declare it once here, and then everything that inherits from C indicator base will also have that function. And the next function I want is getArray. So the difference between metatrader 4 indicators and metatrader 5, in metatrader 4 you call the indicator function and get back a single value based on whichever bar number you request. In MetaTrader 5, set up the handle and then later copy the entire array of values into a buffer, this buffer here. So to duplicate that and make this a common class that works for both MT4 and MT5, I'm creating two different functions. One of them I'm calling getArray, which will perform in the MT5 manner where it returns an entire array, and this is the array that it will be returning. There'll also be another function that returns a single value, and that will work in the MT4 manner. And that way you have the flexibility inside your program to either get an entire array or even a section of an array, or get a single value. And where this might be relevant, typically there are expert advisors that will compare the values from bar number 1 and 2 to see if there's been a change. So by using the getArray, I can get a simple array back of 2 elements that just tells me what the values are in those 2 without making multiple calls to get individual values. Of course, when it comes to implementation of these and writing the code, they will have to be different for MT4 and MT5, but you'll see that soon. So the arguments to the getArray though are the buffer number, which tells the indicator which of the buffers. So moving averages only have 1 buffer, so that would be 0, but a MACD has 2 buffers, so I would be passing in either 0 or 1 depending which of the values I want from MACD. I have a start position, which will typically be 0, which would tell it that I want from bar number 0, the current bar, but you could set that to anything you like. And then count is the number of bars that I want to return. And then because I'm trying to return an array, I have to return that as an argument passed by reference. So it's a double array, same as this buffer. I'm just calling it ARR, and I'm passing by reference by using this ampersand. As an array, it has to be passed by reference anyway, but that's the way that I can return a value in this. And the other function I mentioned was getValue, which will return a single value. So that still takes the buffer number and the index, but there is no count and no array. It only returns a single value, and it returns a double. This keyword virtual inside a class means that the child class that inherits, so when I create the C indicator MA, it will inherit from this class, and it can create its own version of getValue that works differently. And this virtual simply says that if a child class has this function, then use this function from the child class rather than this parent class. And the reason this is virtual and this is not, because when we get to the code, so far in the various indicators I've created with this, getArray function is the same for all of them. Because the difference in the way MQL5 returns values is that once the handle has been allocated, which is custom for each indicator, then retrieving values into the buffer is the same. So the getArray function is not virtual, but the getValue is virtual because I will have to create that for each child class. And then finally I have a second getValue function, same name but different arguments. So I'm overriding this getValue, and this is for those indicators that only have a single buffer, like moving average. And one of the reasons I'll be using both moving average and MACD in the examples are that they show one that uses buffer numbers and one that doesn't. So in the case of a moving average, just to make it easier to use, it's possible to call this getValue, and that will simply default the buffer number to 0. And as you can see, I've written the code here directly. Open bracket, and it just returns the call to getValue, which is this getValue, passing 0 as the buffer number and passing the index from here. Now note, all of these declarations, the getArray and the getValue, are simply the function name and the list of arguments ending in a semicolon. That means that I have to write the body of the function below outside this semicolon in the same way that the constructor and destructor have been created down here. The isValid function though has the open bracket and code written in here. So these are the two ways that you can create code inside a class, either by simply declaring the function and then writing the code below, or by writing the code in line here. And this doesn't have to be a single line, it can wrap around, but I typically only do this for very short functions, like where this is simply returning a value and this is also simply returning a value. anything more complex, and I will place the code in a separate section. And now in the constructor, and this is where we place code that needs to be run when the object of this type is first created. So the first thing I'm going to do is initialize the handle to 0. The invalid handle is actually a -1, so I'm setting the handle to 0 to begin with. The handle is not used in MT4, so if I am calling this from an MT4 application, I'm not going to be setting the handle by setting up an actual handle. So when there is a call to isValid, or if there is a call to isValid, it won't have the invalid handle by assigning a 0 to that. Now, something you'll notice here, compared to a global variable in the application, I can't declare int mHandle equals 0. I simply can't do that in a class. So all variables in a class, if they're going to be initialized, need to be initialized in a function, and typically that function is the constructor. So here I'm initializing the handle to 0. Now the other thing I'm doing here is the array set as series on the buffer, and I'm setting that to true. So this is the buffer that I've declared, and it's only used for MT5. But by simply declaring a buffer, the index of the buffer will be counted from left to right. And the bars on a chart are typically numbered from right to left, with bar 0 being the currently open bar, bar 1 being the bar that's just closed, bar 2 the one before that, and so on. I like to align these buffers to the chart sequence, and that way if I'm referring to element number 0 of the buffer, it matches bar number 0 on the chart. And so I do that with this array set as series, and after doing that, the index of the buffer is counting from right to left and matching the bars on the chart. As said before though, this is not used in MetaTrader 4. It doesn't hurt to execute this statement. It happens once off when the object is being created, and it just means that I'll have a buffer that is not used in the MT4 version. And then to the destructor. In MetaTrader 5, we assign handle based on the indicator. By doing that though, we need to release that indicator when we've finished using it to free up memory and resources. Now it's not used for MetaTrader 4 at all, and the statement itself simply shouldn't be compiled into MetaTrader 4. So I'm preceding the statements with this hash ifdef __ MQL5 __. I know on the screen it looks like a single bar, but there's actually 2 characters here, 2 underscores and 2 there. The compiler creates this compiler variable called __ MQL5 if the code is being compiled in MQL5. If it's being compiled in MQL4, there's a different definition, which is MQL4. So this compiler directive #ifdef means that the code following this is only compiled if this is being compiled with the MQL5 variable set. So that means this statement, indicator release of mHandle, is only compiled if I'm compiling under MQL5. And you'll see more examples soon of the #ifdef MQL5 and the #ifdef MQL4. And we end all of that with the compiler directive #endif. So that takes care of the constructor and the destructor. I also have the getArray and getValue functions that must be created, and they are going to be different enough between MQL4 and MQL5 that I'm actually going to create complete copies of each function using the #ifdef to separate them. So first, the MQL4 version. Now the getValue in the base class, in the CIndicator base class, has no idea how to get a value. That can only be done by the child classes, but because I've declared this getValue, I must create the function in the base class. So I'm creating that function, but I'm expecting that every child class that I create will create its own version of this. So all I'm doing is returning a 0 there. Now the other thing was the getArray function. Remember that MetaTrader 5 naturally returns an array from an indicator, and MetaTrader 4 naturally returns a single value. So for MetaTrader 4, I'm actually going to build the array. So first I'm taking this array argument that was passed in, and I'm doing this array set as series again, just in case it wasn't already a series type array. And then I resize that array to count, which is the number of values that I'm going to be returning. And now a simple loop for integer I equals 0, as long as I is less than count, and I++ to increment that. And then I'm calling the getValue function, which is this, but remember that if this has been overridden in a child class, then I'll actually be calling the getValue from the child class. So when you see the moving average class, it will actually be calling the getValue function from that child moving average class. So I call the getValue, buffer number, and I plus start. So if start is not 0, I need to offset the value that I'm getting back. So I plus start is the argument into the position of the array. And finally, I'm returning count. So the array has already been set by passing through this, and because the array was passed by reference, the values in this array are already set when it returns to the calling application. But I'm also returning an integer value, which is just count, which is the same number that was passed in here. And the reason I'm returning this, in the MetaTrader 5 version, if there has been a problem in retrieving these values, this will actually be different to the value that was passed in. And that's the end of the custom MQL4 section. So you can see the syntax here is the same. The compiler directive #ifdef __ MQL4 __ and then ends with #endif. Now the specific code for MQL5. So the function, simple double type, class name, double colon, and then the function name. So we're doing the getValue function first. You can see that it has the same arguments as the MQL4 version. And this is part of making sure that this class and the classes that inherit from this can be used without the calling application needing to worry about the differences between MQL4 and MQL5. So for MQL5, rather than get a single value, the handle has already been set up, which we will see in the child classes when we initialize the handle. Here in the base class, remember I was just setting the handle to 0. It's up to the child classes to set that handle up correctly. But the copy buffer statement takes the handle to an indicator, the number of the buffer, which is for indicators that have more than one value, the buffer number is the number of which value you want to return. Then the index, which is this index matching the bar number you want the value for, comma 1, and loading that information into mbuffer. Now, MetaTrader 5 does return a buffer, which is an array, but because this particular call, getValue, is only intended to return a single value, that's why I'm calling it with a size of 1. So I'll get back a buffer, but the buffer only has one value in it. And then here, this test if result is less than 1. So copy buffer, although I've asked it to copy only one value in, if it has a problem, it will return the actual number of values that have been copied into this buffer. So I'm capturing that in this result and then returning, if result is less than 1, I'll return 0, which means that this failed in some way. And if result didn't, or if copy buffer didn't fail and result is actually equal to 1, then I return the buffer element number 0, which is the single value that I wanted to retrieve in the getValue function. But in cases where I want to get more than a single value, so bar number 1 and 2 for example, I will call the getArray function, which is the more efficient use of the copy buffer. The arguments here are still the buffer number, but then the start, count, and the array being passed in. So I begin with the same array set as series R to true to make sure that this array being passed in is a series. And then this is the same statement. Result equals copy buffer, handle, buffer number, but this time I'm passing with start and count. So I will begin at a different index point and I will copy in as many values as have been requested and load that into the ARR variable. And then I simply return that result, which is the int argument, which is the int return type for the getArray function. So if copy buffer is unable to copy as many values as I requested, the calling application can decide what to do as a result of that. And then #endif. And that is the base class. There are very few functions in here. All I'm doing is calling the getValue or the getArray. So I'm losing some of the flexibility of the MetaTrader 5 and even the MetaTrader 4 functions. But for most of the work that I do, this covers everything I need. And in those cases where I do need some more flexibility, I can always use the standard technical indicator functions. This is just going to wrap up the most commonly used features for me. And by using this class and the child classes from this, which we will see now, I have a single point of entry that looks the same for me for MetaTrader 4 and 5. So now let's look first at the MA child class for C indicator base. Now with that base class written, first thing I'll do is create a class for the moving average indicator. We'll need to create a class for each of the technical indicators, but I'm not going to do them all today. I'm just going to create the moving average and then the MACD so that you can see the slight difference between the two child classes. So the first child class, the moving average. So again, back to the indicators, right click, new file, new class, and this time I'm going to call it C indicator MA. But I'm also going to fill in this base class field because my base class will be this C indicator base. And here where it says public, I'm going to leave that as public. And now it's created this template for me. And here you can see I have the class statement again. And this time the class name is C indicator MA, and it's added colon public C indicator base. So this is how a child class inherits from the parent class. And this public statement means that the public methods in the C indicator base parent class can be called by programs that are using the C indicator MA class. So it filters them through and makes them public in the child class. Let me just tidy up the comments and the structure a little bit here. So now I've done the same tidying up that I've done before. Add a line there. Comments, property statements, class name we've already discussed. You can see the constructor here is now called C indicator MA and the destructor is tilde C indicator MA. And here are the constructor and the destructor. Now because this is inheriting from C indicator base, it needs access to the code for that C indicator base. So I need to put in an include statement to bring in this indicator base file. And it's as simple as that, include indicator base. I've got it in the same folder as this file, so I can just use the double quote indicator base.mqh. I don't need to include a full path to that. So I also add this comment here. It's C indicator MA and usage. This is the statement, or at least a template of the statement that you would use in the application that's going to be using this class. So it would be, as a typical type, C indicator MA, declaring the variable, which MA is the template name that I'm going to use, equals new C indicator MA, and then the list of arguments to that. We'll fill in the arguments down here a little later. But you'll see this used when we get to writing the expert, which is coming in the next video, and I'll be using the C indicator MA and the C indicator MACD. In the parent class, I have these two protected variables, symbol and time frame. For a moving average, I also need period, shift, method, and applied price. I'm going to create protected variables inside the CIndicator MA class for those. So I'm putting these inside the CIndicator MA class because they're specific to the moving average and they wouldn't be used in all of the indicators. And now the constructor, as I said, this is the default constructor with no arguments. But for the moving average, I actually want to provide all of the information that we need to calculate a moving average. So I'm going to create a new constructor. And I'll delete the default constructor because I don't want that to be used. So the arguments to the moving average are the same arguments you would pass if you're going to call the moving average functions: symbol, time frame, period, method, and applied price. And now remember that in the base class, I declared this get value as virtual. So that means if the child class does not have a get value function with these two arguments, then the base class will be called. But I actually want to create a specific get value function for the moving average because that's where I will be calculating that moving average. And this virtual function simply calls this one at this stage. So I need to create a get value function in the moving average class that will calculate a moving average. And I only want this for MQL4. So I have the compiler directive ifdef $_MQL4 $_, and I'm declaring my get value function. Then it's type double, and it takes the same two arguments, buffer number and index. So it needs to have the same arguments as the parent function. And now I've changed the arguments in the constructor. I'll just delete this one completely, and I'll fill in the constructor that I need for this moving average class. First, the function CIndicator MA class name $: CIndicator MA function name, and then it takes the symbol, time frame, period, method, and the applied price. And now, before I finish the function, before I start the function with the bracket, I've added this : CIndicator base, double bracket. So that's a call to the constructor of the base class. And the syntax is simply, I should have wrapped this around, at the end of the argument list for the function, then a : name of the base class, and then the argument list to that base class. And the constructor for the base class has no arguments, so that's just a double bracket. What this will do, when this constructor is called, it will first call the constructor for the CIndicator base, and then it will execute the code that I'm about to insert in this constructor. Without that statement, then the code in the CIndicator base would not be executed. Now there isn't much in the indicator base. If we go back here, there's just initialization of the handle and setting the buffer as series. But I do want to execute that code. I don't want to copy it into all the child classes, so I'm able to simply execute this by adding that : base class name. And now I'm going to save these values into member variables, into these member variables that I created, plus the symbol and time frame that are defined here in the parent class. I only need to do this for MQL4, but I'm not using the ifdef because saving the values will not hurt in MQL5. So there, I'm simply capturing all of these values from these arguments. And that's because in MetaTrader 4, I don't actually use them during the constructor phase of this class. I use them when each value is called. So I need to store these values so I can make the call to the IMA function in MetaTrader 4. But it's different for MetaTrader 5. In MetaTrader 5, I need to create a handle to the indicator when I first set it up. So for MetaTrader 5, I'm actually going to call the IMA function now. So I've wrapped this in the ifdef $_MQL5 because this function is the same name as the moving average function in MetaTrader 4, but the arguments are different. So if I left this without the if-def, it would try to compile in both MetaTrader 4 and 5 and give me an error if I'm compiling in MetaTrader 4. So I wrap this up. I'm assigning the handle. Function call is IMA. Arguments are the symbol, the time frame, and I've passed the time frame as an integer here, but I'll get a compiler error on this statement if I pass an integer, so I'm just casting that with the bracket enum underscore timeframes. So that's the time frame, and then the period. This is the shift, which I never use. I've never had a need for that, so I'm setting that to 0. And then the method and the applied price. So that will set up the handle. And if that fails, then handle will have the invalid handle value, which we've seen in indicator base. There it is. The isValid function tests if handle is equal to invalid handle. So the calling application should test the isValid after the constructor has been called for the class. So that's the new constructor, and this will be a template for all other technical indicators. And you'll see that when I set up the MACD, I'll simply be copying this MA class and making a few changes to it. And one of the changes will be to simply change this function call to the MACD function call, and then change these variables to the relevant variables for MACD. There's no change to the destructor because the only thing that I need to do in the destructor is to close down the indicator if it's been set up for MQL5, and that is handled in the base class here, and that is always called. So now with all of that done, there is really only one function that's defined in this child class, and that is the MQL4 version of getValue. So that's the only piece of code that I need to write here. Again, I'm wrapping this in the if-def MQL4. Class name CIndicator MA, double colon, getValue, the two arguments, the buffer number and the index. Now I know for a moving average there is no buffer number, but I'm maintaining that as an argument so that I have consistent arguments through all the classes. And remember that here in the base class I declared this getValue that just takes an index, and all it does then is pass buffer number 0 into here. So now the next statement, I'm declaring a variable, I'm just calling it result, it's type double, and here is the standard IMA function call for MetaTrader 4, passing the symbol, the time frame, period, shift, method, applied price, and the index, which is here, which tells me which bar number I want the value for. Now notice that these are also the member variables here, and that's why I saved these values into member variables when the constructor was called, so they can be reused each time this is called. And then I simply return that result, and that's all I need for the getValue function, which is the function that returns a single value for the indicator. And finally wrap that with the hash endif. And that's all of the code that I need for the moving average. And this can serve as a template then for the MACD and all of the other technical indicators. Now I'll just run the compile, which basically does a syntax check, because we can't actually compile an MQH file, but it will run the syntax check just to make sure that the code is valid. And it is, and it's also then checked the code on the indicator base because I've included that in the indicator MA. With the indicator MA created, I'm just going to open this folder and I'll simply copy that to create the MACD, and then I'll come back into the editor and make some changes. So open folder. So all I've done there is copy the file MA, rename it as indicator MACD. Right click here and refresh. I open that, and at the moment it's a complete copy of the MA. So first thing I'm going to do is change all of the indicator MA to indicator MACD. So now the comments fine, properties are fine. I'm still including indicator base. I'll just replace this comment. Right, that ran off the screen a little. I'll wrap it around here. And this is just the arguments then for MACD. So very similar syntax. C indicator MACD, some variable name, which by default I would call MACD, equals new C indicator MACD, symbol, time frame, fast period, slow period, signal period, and the applied price. Standard arguments for an MACD. Class statement's the same, but I've just changed the class name to C indicator MACD, still inheriting from C indicator base as public. The variables for MACD are going to be different to moving average. Let me just delete these. So the variables in a MACD, fast period, slow period, signal period, and applied price, as well as the symbol and time frame, but they are still in the base class. The constructor will change because I have different arguments. Let me wrap this around as well so that it's a little easier to read. Symbol and time frame are obviously common, then fast period, slow period, signal period, and applied price. All the standard arguments for an MACD. This statement doesn't change because any call to get the MQL4 version is still going to request the buffer number and the index, although with MACD there are actually two buffers. So there is going to be the default get value. Let me go back to indicator base. This will still exist and can still be used, and that's going to give you the value for buffer number 0 by default. But if you want the value for a different buffer, which in this case would be the signal buffer, then you would pass buffer number 1. But there's no need to change this line of code. It's identical for it's identical for the MACD and the MA. And in fact, it should be identical for most technical indicators. And the constructor, obviously, this has also changed. For the different arguments for the MACD. But I'm still calling this C indicator base. So the only change here, really, apart from changing the class name, is to change the values, and that's because I have different values for an MACD. And then naturally, these variables that I'm capturing for moving average are not required, but I do need the values for the MACD. Now the two remaining changes will be that these IMA functions now have to become the IMACD functions. And this is the standard MACD function call, symbol, time frame, fast, slow, signal periods, and the applied price. And then in the MQL4 version, the same thing. I'm going to replace this IMA with the IMACD with the same arguments: symbol, time frame, fast period, slow period, signal, applied price. And then this is why I need to separate these for MQL4 and 5, because MQL4 actually wants the buffer number and the index as part of that call, where MQL5 is just setting up the handle and doesn't need this information until we get the values. So that completes the MACD version as well. So I guess what I'm trying to say there in summary, once the base class has been created, and in fact the first indicator has been created, it's a simple matter of copying that, and the changes you need to make then, obviously changing the class name so that it matches the new indicator. Change these variables to the variables that are required for that indicator. Obviously then change the variables passed into the constructor. Capture the variables here in the constructor and then change these two function calls relevant to that particular indicator. And then this forms a template for every technical indicator after that. We'll just go to the MACD. I'll do the compile to make sure I don't have any syntax errors. And I'll just take a couple of minutes and I'll write a script. I won't use these, but I'll just show you how they are called. All right, I've just written this script quickly. First, the includes. I just need to include the indicator MA and the indicator MACD. To use them, C indicator MA, the class name, which is the same as a variable type. A variable name, I'm calling this MA, equals new C indicator MA, and here are the arguments, the symbol, period, just calling for the 50 period EMA on close. For the MACD, class name C indicator MACD, variable name MACD equals new C indicator MACD, symbol, time frame, 12/26/9, and price close. And then to use those, to get a value for the moving average, I'm simply calling ma.getValue, and this will get the value for the moving average for bar number 3 in this case. For the MACD, same thing, macd.getValue. Here I'm passing the buffer number 0, which is the main MACD value, and I'm again getting that for bar number 3. If I want the signal value, I call getValue and I pass buffer number 1 to the MACD, bar number 3. And if I want to get a series of numbers, I declare a double variable of array. That's an array of values, and I call the macd.getArray, and I'm looking at buffer number 0 from position 0, and remember I reversed this, so position 0 is the current bar for 3 bars, so that will get me 0, 1 and 2, and the results will come back in this ARR value. So that's set up the classes for us to use. In the next video, I will actually be writing an expert advisor that uses both the MA and MACD together. And in future videos, I'll also be referring to these classes. And if I need to create more technical indicator classes, I will just quickly copy the MA or MACD or some other template and create a new class. But I won't be going through the structure of these and how to create them again. So I'll simply refer back to this video in future if I need to. I hope this has been useful to you. If it has, please click the like button. And if you want to see more of these videos, remember to subscribe and click the bell icon and you'll be notified when we do release new videos. Until next time, thank you for watching.